So I've taken this old blanket and clipped it in place in the doorway. I'll probably have to get a longer one, but I've done this so that the heat I'm going to use with the diesel heater during winter work here will hopefully stay in the bus a little better. So if you're at least covering this top half of the door will help some. So anyhow, I'll probably cover the side door and the back as well, just to kind of make it a little bit better as far as keeping the place warm while I'm working in here. Okay, so as a little bit of a continuation of the plumbing job, I actually put this clear hose on going around the whirlpool there for the back sink drain. What a pain in the ass that was. This tubing is really difficult to work with. It's very, very rigid, especially when it's cooler. Of course, it's winter time, so inside the bus is a little bit chilly. Got the diesel heater running, as you might hear in the background, but it's still in the 40s in here right now. So anyhow, we'll continue on here. I'm going to clean up and work on electrical next. So this smaller electrical box is going to get moved to the back, and it'll go where the actual entry is going to come in, which is right under that corner where that dustpan on a stick is. Right below there is where the electrical should come in. It's far enough away from the water inlet over here. So anyhow, that box will be positioned over there. I'm going to take it off the wall right now. So what I'm doing right now is actually working on the entry wiring. I'm going to be pushing the shore power plug out through here under the floor. It's going to be clamped to the floor at the top here. It'll come in through this board, and it'll come down through the top there and feed this panel. So I've actually got the box screwed in place. I'm working right now on figuring out what wire gauge at maximum I can use in this RV outlet. I'm trying to use this really thick stuff I already had. I'd like it to be overkill. No sense using a lower wire gauge if I can make this fit. So we'll see if I can trim some ends and get them to fit in there. If they'll fit, then I think we'll use that gauge. Otherwise we'll go with, I think this is 6 gauge. That's what I would want to use at a minimum, as a 6 gauge cable. But I need to roll it out and make sure I'll have enough left to connect from the inverter to the power panel, because that's what I was going to use for that. So anyway, I've got to think a little bit about my notion of having power directed through the inverter, and then have the option of bypassing the inverter to the panel. I may want to get a selector switch of some kind for that. I've got to think about it. For now, I'm just going to wire it so that it only feeds through the inverter, and just assume that the inverter will not fail on me. So until I can get to the electrical supply store and see what options they might have, looking for a safe way to be able to bypass the inverter if it has a failure. So as much as I'd prefer to work with this heavier gauge, I think it's actually 2-wire gauge. To look at the print again, it's either 2 or 4. I think it's 2. It's just going to be too cumbersome. I'm going to stick with, I believe this is 6 gauge. I got to look at it. I also got to make sure I have enough of it to do what I need to do over there and this. So hopefully it's long enough and the right gauge. So I'm going to have to lay it out and find out. So I decided, just to be sure I don't cut too much cable off, I'm going to actually lay it in the channel, get it kind of piped through. I'm going to pop these pieces back out and get this put in. It's going to come in and turn a corner and go right down on this side for the inverter. I'll leave enough hanging there that I'm sure that I can connect it. And then I'll actually wire it up here through there, up into the panel, coming up in from the bottom, and loop it to the top here. So that way I can make sure that there's indeed enough wire to snip here before I donate some to the cause back here. Alright, so I've got the 6 gauge 3 conductor 1 ground here. Got it into the box. I lift enough slack that I'll be able to connect it in the box. Got a clamp down here. I'm going to push this against the wall. Right now I'm snaking it through the floor here. I'll be zip stripping it to this tube as it goes up and down below. But I'm going to clamp it to the wall. It's actually coming through here, and then I'm going to loop it around, attach it to the, zip strip it to the pipe to kind of ease the bend. It's not very flexible. And then we'll get it snaked under the floor over to where the AC side of the inverter is going. Okay, so I've got the floor opened up. What I'm going to do now is snake this cable over here and kind of loop it around behind and cut it behind the inverter there. That way I know I have enough. And hopefully I'll have enough left to do the input from the shore power as well. So hopefully I got this original cable cut at the right length. This may have actually been already looped by Lowe's and I might have bought it on clearance. But anyway, we'll get it roughed in here. So the good news here is it looks like we have plenty of cable to work with. So I'm going to take a quick measurement and estimate about how much I need on that other side. I'll leave a little slack here in case I want to have a little extra in the box if I pull it forward. So anyway, we'll take a measurement, make sure I'm not cutting too much for back here, and that way we have plenty to work with here. Alright, so I've got some cable clamps holding that up above. I've got it heading over that way. I'm going to kind of coil it in there and quit for the night. I've got, well, it's almost 11 o'clock, so it's time to get home. But I'll have to get my brother's wire cutters. I think he has some heavy duty ones that'll easily cut that. So anyhow, that's it for the evening. Back at the bus here. It's Sunday evening. I'm going to go ahead and get this cable cut. And then I'll start back here and finish the entrance cable using this piece that I'm able to cut off. Alright, so I've got these 6-gauge wires stripped. I'm going to get this thing put together. This will carry 50 amps. So this is a 50 amp receptacle. You got to look at your, of course, at your ampacity charts and make sure you choose the right cable when you're working with electrical. So I've got the connections made. Now I'm going to get my multimeter and go from these screws here to the other end of this wire and make sure that I've got continuity on each of the 4 leads. Alright, so I've got very low resistance on each of the 4 conductors I measured from the actual screws here to make sure it was making good contact on all of them. So at this point I'm confident to put the cover on this. I'm going to slide it on from this end. Then we'll get it threaded on. After which I'll be ready to drill the hole on the outside of the bus to accommodate this. I think what I'm going to do is actually drill a 2-inch hole, and then I'll have to widen it a little bit with the jigsaw. I got to take a look at the well, I might actually just want to jigsaw the whole thing. I'm not sure, but I'll have to take a look at what's the easiest way to do it and where it's going to fit. So anyhow, first put the cover on. Alright, there it is with the cover on. I'm told this is 2.4 something inches, or almost 2.5 inches. I'm going to measure it, and then I'll figure out the hole I need to put on the side of the bus here. Alright, so I don't have a 2.5-inch hole saw, so I just kind of scratched the surface, and now I'm drilling these holes. I'm going to come in with the jigsaw and just kind of catch the perimeter here. Okay, so it pays to look around the shop. My brother happened to have a 2.5-inch hole saw, so that's good because my jigsaw gave up. It's a cheap Black & Decker I've had for years. It finally quit holding blades, so I couldn't get the cutting started. But this will make short work of it with the hole saw. Okay, so there we go. I actually need to possibly notch this piece of wood a little bit. I'm going to put the hole saw through as far as I can, and then I'll come at it with a little handsaw and notch it just a bit. Alright, so I've notched the wood inside. Now what I'm going to do is use this little countersink bit to create a little bit of a recess in the plastic. I've got some countersink stainless steel screws I'm going to use in there. Maybe just a little bit short, so if we countersink them it'll help. It'll also make it install correctly, quite frankly. This comes with a foam backing, So I'm not going to use the the heck am I saying? The putty tape, whatever you call that stuff. I can't remember the name of it. So anyhow, I'm going to get the countersinks in, and then I'll drill some pilot holes and get the stainless screws put in. All right, so there we go. I've got these all countersunk fairly nicely. And it's nice and secure. I think it's pretty level. It's kind of hard to drill holes and get things perfect, but anyhow, that is installed. Now I just need to take the wire from it and get it into that panel, and wire clamp it in place. All right, for the next step here, I'm going to use the hole saw and drill a hole up under here so that I can run the wire through to the top of the box. Okie doke, so got the 6-gauge wires in place here, strain relief. Got some hanging here, it'll get tacked up into the ceiling. I'm going to screw it in with one of those rubberized stainless steel clamps, and that'll keep it out of the way. So the next step here would be to strip this back and figure out where I'm going to put it in place, but I need to buy the particular breakers. The ones I had aren't going to be the right amperage for the most part, so I got to think through this plan, look at the input, and I'm actually going to also run an outlet from this. I'm not sure exactly where I'm going to put it, but there'll be an outlet or two that are designated as shore power outlets in case we're having problems with the inverter as a power source. If it fails or whatnot, we'll still have some outlets we can run extension cords from. So anyway, I'm going to continue this tomorrow. Pretty good progress for one evening. Right, so I went ahead and secured that with a rubber clamp. All right, so because I'm inside a big Faraday cage and the Wi-Fi from the shop over here was a little bit weak, I've got an extender set up. So far it works pretty good. So anyhow, a little cheap $30 extender, and that'll make it so my calling inside the bus works better on Wi-Fi calling. Okay, so I'm back at the bus. I went and picked up a roll of 10-3 cable, about 20 feet of it. It's going to go from the box over here on a 2-pole, I think 20 or 25 amp breaker. So far I've got a 20 amp 2-pole breaker. I might be able to swap it for 25 amps. The reason is I want to limit the current going to the inverter, but this run's going to go from the shore power to the inverter, and if I can get an interlock for that panel, then I'm also going to have the ability to run shore power junction directly to the panel and just interlock between supplied by the inverter versus supplied by the shore power with the flip of a switch. So I need to find an interlock for that QO panel between two opposing double pole breakers. So we'll see if the internet can help me with that, or an electrical supply house or something. But anyhow, for now, the next step is to get this cable over that way, and we're going to finish wiring this load center here. You know, I may later, like I said, swap it for 25 amps. Either way, this cable at that distance will be sufficient gauge to carry the current. I believe this will be rated for up to 30 amps. I'll have to look at the chart again, but I think it's good for up to 30 amps. So anyhow, I'm going to get at it. Alright, so I've started wiring the shore power into this breakout panel here. So right here, I've started with the ground onto the ground bar. You can tell this is the ground because it's connected to the outer case. On this RV wiring, this functions as a sub panel, not a main panel. You do not need neutral ground bonding. In fact, it could be dangerous. When you plug into an RV park, the neutral and ground should be bonded at the source upstream at the main panel in the park. So this one should function as a sub. So I'll make sure there's no bonding here. I don't see a bonding screw on this panel anywhere. So the next thing I'm going to do is connect the white wire to the neutral over here, and then I'll install the breaker, a 50 amp breaker, which will be the L1 and L2 for, you know, the hot legs, the black and the red wires. Okay, so here we go. I've got hopefully L1, L2, neutral, and then ground all wired up. So I had to run the shop 6 times to find the right T-bit. My brother's shop is kind of a mess, so I'll have to take that, put it away. Right here next, I'm gonna put a strain relief in, probably right down in here, and then we'll put the breakers in, the breaker in for the line that's going to feed the inverter. Up here, I'm just going to wire some, at least probably 2 outlets, direct to shore power, going out this way. I'm not sure exactly where I'm going to mount them, but they'll be useful for should the inverter have a problem. But I am thinking of trying to do a lockout in the main panel as well. So I've got to find that online for the QO panel, the load center on the other wall. So the next step here was to use these stainless steel rubberized clamps and get this cable secured. And I've got a tube here, hard side, almost like PEX tubing, that this fit into, and it runs beside the whirlpool to keep it protected. And then I've got it going through the notch on the other side that'll be under the floor in the hatch. I'm at the bus here, got a little bit of time to work. I'm going to continue on this 10 gauge cable, running it over here to the inverter. I'm going to actually take that cable and I'll cut it at a length just behind the inverter over here, and then I'm going to use connectors, 4 of them, that are designed to connect multiple cables together. And then one cable is going to go to the inverter feed, and then the other cable is going to go up into the panel directly. So I'm not sure where I'll make that connection. Maybe right in here, actually. But for now, I'm just going to get this stretched out and cut that section to length. As part of the process of running that 10 gauge cable, I'm actually building these covers for the battery. I'm going to have the battery management leads come up through here. I'll need to drill a hole for the negative battery lead to go down from the BMS over to that terminal, and then the positive wire will come along here. The reason I'm building these now is because I want that wire to be below them. I'm going to re-screw the terminals, or the holders, sorry, the line holder, and then I'll run that one underneath it and maybe zip strip it in place to this one. So anyway, just had to get this made so I could proceed. Alright, so that's what we've got. I'll probably put a little elbow piece of metal here and go 1 screw down, 1 over once I get some shorter screws. I also need some shorter screws to mount the battery management system. You can see it has a little hole tabs for screwing it in place, which I'll do. I assume it has, yeah, it has 4 of them, although these look to be, can I get to them? Yeah, just with the little bit of clearance on the wires. So I need 4 screws to hold this down. I'm going to go with 3/4 wood screws, and that'll just kind of set right on top, as well as a smart shunt. So I'll probably get it so that it's on this side so that I can weave the battery cable down. I'll lay it in place and then figure out where I need to put the hole to, or the slot perhaps, to get the battery cable down to the negative. Alright, so I've got the wire kind of fished through here. That's where I'm going to stop for the evening. Feeling a little tired today, so to get home early. Anyhow, I'll wire that in place, get it trimmed over here to the right length, and I got to estimate here whether I have enough to bridge from over here up into the panel or not. Okay, back at the bus here, working on electrical. I actually bought the wrong interlock, but to complicate that a little bit as well, I need to move these 2 breakers down to put a 30 amp in. that 30 amp will be from the inverter to this panel. And to prevent backfeed, that interlock will either allow current from the outside power or from the shore power to come through this breaker, or it'll allow current to come through this top slot where I'll have a 30 amp 2-pole breaker coming from the inverter, and only one can be active at a time. So it's similar to this, the one that I need, but of course, you know, almost twice as expensive. So anyway, I got to get the right one. I'll have to return this one. So what I'm doing right now is trying to move these breakers down. I got one that's a little bit tight. I'm going to have to move which knockout it comes in through to get the amount of wire I need to move it. Alright, so I was able to get this 30 amp double pole breaker in place. This will be, again, where the inverter power comes in, and this will be either the raw shore power or raw generator power bypassing the inverter. Only one will be on at the same time with the interlock, so we'll get to that later once I get the right interlock. Okay, so right there I've wired the 30 amp breaker to come from the inverter. Line 1, line 2, neutral, and then the ground is right here. We're going to go ahead and put this, make sure this is an off position, and same thing with the main here. Now I'm going to wire the shore power into the panel here. What I'm going to do is I actually have 4 of these wire couplers here, and I'm going to bridge this 10 gauge cable through these couplers, line 1, line 2, neutral and ground, and then one part of it will go up to the panel and one part of it will go over to feed power to the inverter. So that's shore power to the inverter, and that'll be up to 20 amps per leg from shore power, so well below the 50 amp plug. I'm only wiring it that way so that if I change it in the future, you know, I don't have to change out the plug connections. So, and I also don't know exactly what I'm going to have. So the inverter will always feed 220 out, but the shore power could be 110 and only power half the panel if we weren't feeding it through the inverter. So the whole reason to have the interlock is so that if the inverter fails, that we have the ability to feed shore power to a reasonable amount of the bus outlets. So it's not exactly the best answer, but or if it's a 220 feed in, we can feed power to all of them and bypass the inverter. But if it's only 110 and the inverter's having a problem, we can still feed half the outlets. So that's what the design is, and that's why the interlock is critical. Alright, so I've added the snap-in 3/4 inch strain relief. Now I'm going to feed the wire up in through. And this will help me position where the wire splitters are going to go. And I'm hoping I have enough 10 gauge already to do it all. If not, I'll have to buy some more wire. Alright, so I've got the wires separated here after this is entered through the strain relief. Now I'm going to join the black and red at the top for the 220 volt feed, and then we'll feed the negative with the white and ground out the green, and we'll be wired to the box for the main power sources. And then I'll stretch this out and see if we can cut it at the right spot down here to use these connectors. And the idea is to spur the power over to the inverter in the input side for battery charging, and then we'll be pretty well wired for the power source from shore. Alright, so to secure these wires as we're in motion, I actually just used some color-coded tape matching the breaker here with the tape. This is, I'm sure, not electrical convention, but I don't have to necessarily follow residential code in this build. I just have to make sure it's safe. So this tells me that this wire here is the shore power when I'm identifying the wires coming out of the box with the box lid closed. I'll be able to look at the breaker and go, oh yeah, that one's that and that's that. And I'm going to label these as well, but color codes never hurt. So anyway, I've wrapped the the wires a bit to keep them from jostling around too much. Keep them where I want them. So the power feeds are in place. Just got to get that interlock. I've ordered a replacement for the wrong one that I bought. So anyway, I'm going to keep going here. Alright, so what I'm going to do is take the short power feed, which is going to operate at 20 amps per AC leg, based on the breaker I've put in the box over that way. And I'm going to connect it with these. These are designed for car audio. They're very hefty and will accommodate these larger wire gauges. So there's going to be a black, red, white, and ground. The ground will actually also tie into the DC grounds for the equipment cases, the negative bus bar of the battery, etc. And then I'm also going to strap the ground for everything, AC and DC together, into a lug. There'll be a wire going to a lug that is on the bus frame as well. So the grounds will all join together on this block, but it will also be tied into the bus frame. So to get these wires to be secure in these lugs, I'm actually using just Buchanan crimp ends as a ferrule of sorts, crimping them on, and then I'm lugging into them. The lug digs in pretty good with the solid copper. So didn't have any ferrules handy, but these are just as good in my opinion. So anyway, I'll keep moving here. Okay, so I'm like midway through this process with these blocks. I'm going to go ahead and get a 12 gauge 4 conductor Romex and extend. Since I don't have enough of this wire, I'm going to extend with that Romex over to the inverter. It'll still handle 20 amps per leg. It's fine. So I have some of that laying around. I'm going to test its continuity right here. This stuff here. Test the continuity, and on a short run like that, I'm sure it'll be just fine, since Romex 12 gauge handles 20 amps anyway. So anyhow, I'm going to go ahead and, like I said, check continuity, and then I'll fish it through and lock it down on this side, and then we'll do the same with the ground. I want to have the ground angled in such a way that the wires that are going to go that way are easier to put in. So anyhow, proceeding along here. Alright, so the continuity on this Romex with 4 conductors, 3 conductors with the ground, tested fine. I snipped it to size and weaved it under there. What I'm doing now is folding these over so I can put the crimp connectors on, crimp them as ferrules, and then I'll put them each in place. Then we'll pull this back and kind of fit everything together, kind of bundle up the wires. And I've got to figure out what I want to do. Even though this is under the floor, I need to come up with some safety measure, because this is higher voltage. It's a potentially lethal voltage. So I think I might build a cover over this with wood, just to keep people away, even if we're, just putting storing items under here or something. I'll probably build a wooden cover to kind of shield this from moisture and contact with hands. Even though there are plastic covers here that I'll tape on, I just feel better kind of hiding this with something. So that's what I'll be doing later. Alright, so I've got my AC input junctions here. I've got the covers on them. I'll eventually, like I said, put a wooden cover over this, wood or plastic. This is where I'm going to join the ground bar here with the frame grounding and equipment grounding. So the inverter, the charge controllers, etc., they'll all be lugged together with this and the vehicle frame and the negative bus bar from the batteries. Okay, so for the sake of clarity, I've labeled shore power either 120 or 240 volts, 20 amps times 2, each leg is 20 amps. And then we've got 240 volt, always 240 coming from the inverter. So that's those. And then that device to isolate these, or what's called a I'm struggling to remember. Interlock. The device is called an interlock. Basically, when I want to turn one on, it forces the other off. So the direction for on and off on these are different. So this is the on position for that one. So, and this is the on position for this one. So it'll slide horizontally, where they're both, this one will be on and this one flips off at the same time. So in essence, you've got to disconnect one to connect the other. So that keeps power here from back feeding to the inverter and blowing it up. So, and then also it keeps the inverter from supplying power when the shore power is touching the panel here. Now the shore power is always going to be hot to the inverter when it's on, as far as charging the batteries goes. So, but it won't be accepting power from the inverter is the key thing. So anyhow, that's it for the evening. I'm going to head home. All right, so I'm back at the bus here. Today's order of business, now that I've got the shore power wired to the panel and over to the inverter, today's order is to build the extension cord outside for up to 50 amps of service. I'll never actually use that much because of how I have it wired. It's unlikely I would ever use 50 amps. But I do want the possibility to exist. So anyway, that requires 6 gauge, which I already have here. This is my welding extension cord from way earlier in the project. I'm going to reuse this expensive cable, and that'll be, you know, our shore power cable when I'm done. So I'll take these ends off and put other ends on. All right, so I've stretched this welding cable out. I believe it's a 50-foot long cable. I'm going to actually preserve a welding extension cord by only using part of this and swapping ends, because we do still do welding. So it's handy to have an extension cord for that, but it doesn't need to be 50 feet long. I did it that long because of having to use it for the bus from the shop before the electrical went out in that shop building behind the bus over there. So anyway, I'm going to probably chop these into, thinking 2 lengths at 25 feet is what I'm going to do. One's going to be for the bus, the other I'll fashion back into a welding extension cord for the shop over here. Okay, so I cut that 6 gauge cable at the right length. I decided on 30 feet for the RV cord and 20 feet for the welding extension cord that was left. So I've got the ground plug loosely put on, as well as these other plugs. I just got them kind of fit so that I can wiggle this into shape or into place in that plastic housing, and then I'll tighten them down once they're in place. I've got them kind of roughed in at the right distance roughly. So working with 6 gauge cable is not easy. So I also put the bushing on first. So anyhow, I'm going to get this fit in and tighten down. Okay, it wasn't easy, but I have the conductors all tightened up here. Now I'm going to put the outside cover on it. Alright, so there we go. We got the receptacle end. Now I'm going to work on the other side of this. Okay, so I've got this put together. It wasn't easy. It was quite difficult this time. I'm not sure why. I got the weatherproof cover on. So I'm going to go plug this in, and then I'm going to take the plug end over here. Where is it? Right there. And I'm going to hang that out by the box here, and then I'm going to continuity test each lead and make sure that nothing's cross-connected and that we got good continuity between them. But that might actually wait till tomorrow night. I'm running out of time here this evening. So I'm back at the bus here for a couple hours. Tonight I have the correct interlock for the panel. And I'm going to first start with the panel open. I'm going to test continuity and resistance for each of the leads. Red, black, white, and ground. You know, that would be the hot leg number 1, hot leg number 2, the neutral, and the ground. I'm going to connect that on the outside of the bus, make sure the breakers are on all the way to this panel. And then I'll be checking resistance between the receptacle pins there that I'm pointing at and the actual bus bars or one of the circuits associated for each of them. And then also to the end of the lead that connects this generator. Once I'm certain that that has good continuity and the plug is satisfactory, I'm going to I'll at least be testing I don't know if I have the right receptacle for 220, but I'll at least test the 110 adapter. I have a dongle to adapt to 110. I have to see if I have the right one for the shop 220 that's by the door. I might. I don't know. But anyhow, we'll do as much as we can. My hope is that I get some live outlets on the wall by the end of the evening here. Alright, so I've got the thing screwed in place in the twist lock, weatherproof cover and all. Got it fishing inside right now. I'm gonna take the plug itself and wherever the heck it is, right here, and I'll be, like I said, testing these leads with my multimeter. Okay, so the first thing I'm going to do here is put these on so the continuity runs through these breakers, and just glance again, make sure I didn't forget anything. Should be good. I'm not actually going to power things up until I'm sure that the continuity is all happy. So anyway, I'm going to go now with my multimeter and start probing and making measurements of the resistance values. Okay, so actually it's a good thing I was testing with the multimeter. I didn't have continuity on the neutral here. It looks like the continuity is lost between this pin and the first panel here. So it's in one of these three connections, either this one, the other end of the line, or that one. So I'm going to disconnect the line, and I'm going to test the cable first to make sure the neutral has continuity. That'll divide the problem into either that or one of these two ends. So it looks like I'm taking things back apart. Alright, so I tested, I verified continuity with the neutral, both off of this and on the inside from here. So this cord's okay. It may have been how I had it screwed in. I might not have been making good contact on the neutral. First time I've tried to use it, I might not have had it twisted in properly. So I'm going to get some better lighting out there and try it again, and then test again. I hope that's it, because I really don't want to take this apart. So, because I'd have to undo it at the panel. It would be a real pain in the butt. So, anyhow, let's hope I've got it correct. Just maybe I twist locked it incorrectly, not solidly enough or something. Okay, so I still got nothing for continuity. Problem's likely right in here, or it's a bad piece of wire. So I've got to redo some of this that I already finished. So I've got to undo that from the outside, pull it through, check it, etc., etc. Must have a bad connection or the wire's broken. Okay, I might have found the problem, hopefully. I think I pushed this wire in too far when I screwed it down, so I'm hoping this is just squeezing plastic and not wire, and that might be the problem. So I'm going to pull this back out, and I'll just test this wire for continuity before I screw it back in. Actually, I was looking at the incorrect wire. It's so easy. So I need to get the hex key and undo this one. Could still be the same kind of problem, hopefully. Well, unfortunately, the multimeter's telling me that I've got no continuity from the wire itself to the end of this. So either I've got a really bad connection outside, or I've got a fault in the wiring on this part right here, or the wire itself has a break, which is hard to believe on 6 gauge because it's so thick. But what I might do is twist a piece of Romex to this, take it outside, and see if I've got continuity between that box and that wire. That way it'll tell me if maybe it's the twist lock that's broken, and maybe I have a defective end here. I don't know. We'll figure it out. Alright, so I've got wire. I checked its continuity. This is to test with. I braided it to the, twisted it to the neutral lead in here coming from the outside wall. Now I'm going to take the other end of that wire and test continuity to the outside and see what we have. That tells me whether I need to disassemble this or not. Alright, so unfortunately I need to disconnect that and disconnect it at the panel, and probably I've got a loose contact or something on the neutral. That's what I'm thinking. Most likely on this part of it. Okay, so I got the 6 gauge wires fished out of the box. Now I'm going to remove it from the outside and we'll test it. And there is the problem. I just pulled this off and I found that this one had pulled out, and this one also is a little bit loose. Still making contact, but it looks like it's pulled out some, so there's the problem. When this thing got put together, it must have yanked this out. I think I forgot to screw this down tight enough. It feels pretty loose right now, so anyhow, I screwed up. I recommend testing continuity each step as you build stuff. That's where I went wrong on this, but I'll fix it. Alright, so I redid this whole thing. I'm going to test continuity, close it up, test it again, and then we'll reinstall it. Okay, so I got that complicated piece of crap, put that back together again. I'm going to fish it through and get it connected. Everything I've bought specific for RVs has been hot garbage. I just don't like the way this stuff is built. Somebody needs to come along with a better method than this weird tiny screw pot metal chintzy plastic stuff. It's very hard to work with a lot of this RV crap. So anyway, I'm going to get it put in place. Okay, so I have this thing reinstalled. Now I'm going to fish the wires and get it reconnected to the load center. Alright, so now I'm finally ready to retest here. We're going to go all the way to the endpoints again with the multimeter and this plug. Okay, so I taped up this bridge to shore power line that's for the inverter because I'm not ready to connect it yet. I'm going to tuck it under the floor here. I've got wire caps on it for safety. So we'll put that right down there where it's not going to touch anything. And now I think I'm going to go ahead and test the shore power. I've got a little outlet tester. About half of them will work. I'm going to use a 110 bridge plug. You see the yellow plug there. It takes the 50 amp down to 50 amp 240 down to a single 120 leg. So about half the panel will be connected with power, enough for me to plug into the wall outlets, or some of them anyway. Okay, so I've got the breakers turned on. I'm not sure which leg is hot yet. I've got it plugged into the shop on 120, so only half of these will work. But I'm going to go ahead and outlet test and see which ones, if the ones that work, if they're wired properly. Just make sure I don't have a problem. And right there we have success. I set the GFCI on and there we go. I'll test the remaining lights. Any that light up should have the 2 ambers on if they're correctly wired. The other ones, if they don't light up, are probably on the other leg. So until I get 220 hooked up on shore power, that's not going to really function. But the goal here is to be able to bypass the inverter on shore power and have enough functional outlets that we can get things done. And then I'll have to make sure that the primary leg is wired for things like the essentials, like at least the air conditioning or the heat pump, etc. So that if we're having a problem, we can run heat. So anyway, this is a success, and next step here is going to be to move on to setting up the inverter now that I have some shore power feeding in. Alright, it's the next evening. I stopped at Lowe's to get some stuff for the next project here. That is this 50 amp RV plug. We're going to get it into a breaker in this panel over here in the shop, and I'm going to mount it right here. So anyhow, I've got to kind of drill a hole in the back of this box. We want the wire to go straight through the wall, and then we've got a plate here for siding that will eventually go on. So I'm going to put it on this as well. So anyway, I'm going to get at it. Okay, so I've just drilled a hole in the back with a hole saw. It's 1.25 inches for a 1-inch knockout. I'm going to test fit it. Hopefully my measurements were correct in the store. Okay, so I've got the knockout in this box. It's going to have a little bit of a hole into the wall. That way it won't interfere with the siding at all. It's got that relief plate, and then I've got the 2 hot leads, the neutral and the ground wired. I'm ready to bend these wires and tighten up this on the other side so that we've retained that for stress relief. But we'll get these wires bent out a little bit so that I can push this into the case, and then we'll be ready to proceed with the mounting process. Alright, so having learned my lesson about checking continuity, as you go. I've got this box put together. Hopefully I can get this lid closed. These 6-gauge wires are very stiff. But anyhow, the continuity is good right now. Hopefully after I tighten these a little more, make sure they're good and snug when I put this lid back, we're not going to have any wires slip out of their receivers. So I bent them a little bit so they would compress. So hopefully we get this thing put together. I've got to screw it into the wall through that plastic piece. But first I have to drill a hole in the wall to run the wire through. I've got it clamped in the back, and I've got in the plastic enough gap to hold that clamp, and then I'm going to drill a fairly significant hole through the wall. We can spray foam it from the inside when I'm done. Alright, so I've got the hole drilled through the wall for the wire. I've got the siding spacer. Now I'm going to screw the box in through this into the wall with 4-inch screws. After that, I'll be able to wire the 6-gauge to the box with a 50-amp breaker. Okay, so we've got the spacer for siding, and then the box. It's good and sturdy. It's not going anywhere. I got the 3 long screws into the OSB. We're gonna push this in, hopefully without disturbing these wires. I've got them pretty tight, and then we'll screw it in place. There's basically one screw right in here for this case to get kind of tucked into. Doesn't seem very sturdy as far as that opening goes, but it's got these divots here that hold it in place, so hopefully it'll be good enough. Alright, so I've got the box installed. It wasn't easy to get that in with a 6-gauge wiring. I don't know why industrial designers do this, but you have to use 6-gauge because it's 50 amp. But the way they built it, it's really challenging to get it done. And they should have had a knockout. They should have built it so you could knock it out through the back instead of just through the bottom. That's probably why I had trouble. I had to modify it so that I didn't mess with our siding plan here. Alright, so my next step will be to wire this end up into the box here. I've got a 50 amp breaker here that my brother had laying around. It fits this box, so that's handy. Anyway, here's an extra slot down here, over here. We can use that for this circuit. Alright, so I just added this line to the box. It's wired to this breaker down here, 50 amp. So I'm ready to test the voltages outside and plug in the 220 connector and see what we got. Alright, so I just measured the alternating current voltages. We have 120 between this pin and either the neutral or the ground. Same thing here, 120 roughly between here and ground or neutral. And then each leg, I put the prongs in here, and I've got about 240 between them. That's exactly what we should see. So I'm ready to plug the RV connection in. Alright, so there we go. I should be able to go into the bus, and all of the outlets should test correctly with the plug tester. Alright, so the test plug has given me good results on every outlet that I've wired so far. So both legs are hot, and we're good to go here. Pretty satisfying to be able to take all these extension cords I've been relying on out of the way now that I can plug into the wall outlets. Little things. So the last step in this AC power feed process is going to be this interlock on the panel. So I'm going to go ahead and get this installed. Alright, so I have this interlock in place. Now I'm going to go ahead and, well, I think before I put this panel on, I'm going to make note here of what the circuits are based on my existing labels. So that'll be helpful. Okay, there we go. I got it labeled for all the circuits I've added so far. I'll be adding some more, you know, for the whirlpool and things like that. But for now, I'll put the cover on for safety's sake. And got the interlock in place so that the shore power or the inverter can be on, but not both at the same time. So that'll keep us from burning up the inverter and possibly causing a fire here. So good stuff. And at this point, I've got everything labeled. I've got the cover on for safety. The interlock keeps us from having the shore power and the inverter power on at the same time to the panel. The shore power will always flow to the inverter as long as the breaker in the back of the bus is not tripped. So at this point, the shore power feeds are all done. The outlets in the bus are working. I feel gratified. It was quite a bit of work to get that, mostly the 6-gauge cable I was using. It was the hardest part, but to get everything put together. And at this point, no more extension cords are needed to feed power to the bus, so that's good. Just the RV plug. The next step, like I said before, is going to be the, well, under the floor here, the battery bank is under here. We're going to get the battery management system hooked up and the inverter hooked up, and then we'll have the ability to store power on battery and feed AC to the panel if we're not plugged in, as long as the batteries are charged up. Once we've got that step done, then we'll move on to the DC charging side with solar panels. I'm going to have some fabrication work to do to build the solar panel racks for the roof. So anyhow, that's it for the AC shore power input.